Go, guys. It's going to take me just a second for the Elmo to kick on. And then we'll start up this final review video session. Hopefully you guys have seen. I've already posted the keys to the other 4 reviews. So hopefully that'll help out. And we're going to get rolling here. Okay, what are the exact solutions to the equation of this? So remember, with 2 logs, we have to combine them to 1. Because their bases are the same, we can do that. Apologize for my voice. Addition in log land is multiplication. So I'm going to take x plus 3 times x minus 3. It's going to equal 3. Then I'm going to take 2 to the power to undo the log. And I get x plus 3. X times x is x squared. X times negative 3 is a negative 3x. 3 times x is positive 3x. Those will cancel. 3 times negative 3 is negative 9. Equals 8. Now, I could add 9 over. I would get x squared equals 17. Take the square root. And I get x equals plus or minus the square root of 17. The only thing now I need to do is check and make sure that when I plug the square root of 17 in for x, I don't end up with 0 or a negative, because I cannot take the log of 0 or negative. So the square root of 17 is a little bit bigger than 4. A little bit bigger than 4 plus 3 is positive. A little bigger than 4 minus 3 is positive. Square root of 17 is good. Negative square root of 17 is a little bit bigger than negative 4 negative. A little bit bigger than negative 4 plus 3 is a negative. Negative is out. Positive of square root of 17 is my only answer. And we're done. Exact solutions to this equation. But there's only 1 log, so I just have to get rid of it. I get rid of a log by taking the exponent. 4 is the base. 2 now becomes the exponent. That simplifies, giving me x minus 2 equals 4 squared, which is 16. Add the 2. X equals 18. Again, just check to make sure when you plug it in here, you're not going to get a 0 or a negative. You're good to go. X equals 18 is the answer. To get rid of e, I have to isolate it first. Divide by 3. That'll give us e to the 2x plus 1 equals 5. Now to undo e, I do a log, but not just any log. A log base e, which is a natural log, ln. So I take the ln of both sides. It's going to give us 2x plus 1 equals the ln of 5. Subtract the 1. Now remember, this is like ln of 5 minus 1, then divide by 2. And right there is your solution. Done. Number 4 says, consider the following polynomial. Given that x equals negative 2 is 0, what are the other zeros? So I would tell you to go ahead and synthetically divide. We have a 1, a 0x squared. Notice there is no x squared here. A minus 7, a minus 6. Drop the 1, multiply, add, multiply, add, multiply, add, 0. That's a good sign. Yes, negative 2 is a 0. This now became x squared minus 2x minus 3. Immediately go to hippo butt. X squared is what times what? Factors of negative 3, add to negative 2. Negative 3, positive 1. So the other zeros would be at x equals 3 and at x equals negative 1. And then, of course, your third 0 was x equals negative 2 that they gave you. And we knew we were looking for 3 because of that right there. It says write a 5th degree polynomial in factored form with x minus 2 and x minus 3 is only zeros. You got a couple options here. You can have x plus 2 times x plus 3. Now, the only thing is that's going to be an x squared. So you could do a 2 here and a 3 here. You could have switched it. Done a 3 here. 2 here. You could have done a 1 here. 4 here. A 4 here. Or a 1 there. And that's it. Those are your options. What's the domain and range of this graph? Okay. Or this function. Sorry, this function. Again, if you think about what I told you just a second ago, the thing you cannot take the log of is 0 or a negative. So the only thing we really got to be careful about is right here. We need to be careful that this x minus 7 does not become 0 or negative. So in other words, x minus 7 has to be bigger than 0. Add the 7. So x has to be bigger than 7. That's a restriction on the domain. So my domains would be from 7 to infinity. On a log graph, there is no restriction to your range. It's just negative infinity to infinity. If you remember the graph of this thing, we always use the base, comma 1, and 1 comma 0, and this vertical asymptote, so it looks like this. Then we need to shift it 7 to the right and up 9. So each point, 1, 2, 3, 4, 5, 6, 7. This point, 1, 2, 3, 4, 5, 6, 7. And this vertical asymptote, 1, 2, 3, 4, 5, 6, 7. And then get shifted up 9, up 9. So the graph looks something like that. And again, you can see the domain is restricted, but the range is not. Okay, 7 says, what is the domain and range of this function? Okay, well, we could graph it. Couple things to remember. On an exponential, our domain has no restriction of what comes out, or goes in, sorry. I can put anything in there, 0, negatives, it doesn't matter. Anything on an exponential. So we're good on domain. The range, on the other hand, will be different. If it was just e to the x, that's exponential growth because it's 2.71828 going on forever to the x. So this is exponential growth looking like this. The inside is a horizontal shift to the right 2. So this point here gets shifted to the right 1, 2. So all our graph does really is get shifted to the right 2. Then it gets vertically stretched. So in other words, it gets kind of skinnier. Then it gets shifted up 6. So this horizontal asymptote right here gets shifted up 6. Your graph's going to look like that. So you can see the range is going to go from 6 to infinity. Done. It says, what is the end behavior? Okay, I look at the degree. The degree is odd. And I look at the leading coefficient. It's positive, which means here's my end behavior. What does this mean? This means as x goes to negative infinity, f of x, as you can see, is going down to negative infinity. Over here, as x is going to infinity, you can see the graph is going up to infinity. There's my end behavior. Done. What's the end behavior here? Well, if I'd multiply the biggest x exponents together, I'll get negative 6 x to the 6th. 6 is even, so my degree is even. Leading coefficient is negative. Means end behavior looks like this. What does this mean? This means as x goes to negative infinity, f of x also goes to negative infinity. And as x goes to infinity, f of x on this side goes to negative infinity. End behavior. Done. Write a sine equation for the respected, or for the graph. Sure. Notice first I would look at my midline. It's 0, so plus 0 at the end. The amplitude looks like it goes down to 3 and up to 3, so the amplitude is 3. It does start in the middle, so that's going to be a sine curve. But then it goes down, so it's a negative. Now we just need b and theta right here. So b is always 2 pi over the period. My period in this case is pi. So b is going to equal 2 pi over pi, which is 2. So there it is. There's the equation done. Could you write a cosine equation for this? Well, hopefully you could. You know the amplitude is not going to change. You know your midline is not going to change. This is now going to be a cosine The only thing that really is going to change is b. Why? Because we have to shift it back. Looks to me like we shift it back a pi over 4. All right, so the period doesn't change either, so the 2 theta doesn't change. Sorry, the amplitude right in here is going to change. I'll give you guys a full class ticket for that. So we have to go back, so it's going to be a plus pi over 4. Because that's a 2, though, yeah, no, then it would normally look like 2 times, you could write it as 2 times theta plus pi over 8. Either way, we're good. Okay, what are the solutions to this equation? Cosine of x equals negative square root of 3 over 2. Okay, unit circle. Cosine is the x value. So where is it? Negative square root of 3 over 2. That's going to be the long one. That's here and here. And it's in radians. So that's 5 pi over 6 and 7 pi over 6. So where's the solution to this equation? Divide by 2. You get sine x equals the square root of 3 over 2. Sine is the y value, so it's my long y value. It's here and here, again in radians. That's pi over 3, 2 pi over 3. So there's my solutions there. Okay? Find the solutions to the next one. Add the 1. Get cosine squared x equals 1. Take the square root. Cosine of x equals plus or minus 1. Well, on the unit circle, cosine is the x, plus 1 is here, negative 1 is here, so that's going to be a 0, pi, and a 2 pi. The position of a pendulum from its center point can be represented with the function of this, where p is the position of the pendulum in feet, and t represents time. Describe the path of the pendulum, how wide it swings, how long it swings back and forth for, etc. Well, this amplitude 6 is going to be its, how long it's, so it swings 6 this way, and it's going to swing 6 this way. So how wide it swings is a total of 12. So that distance there we're looking at is 12. So how wide does it swing? 12. For how long does it swing back and forth? Forever. Because a sine and cosine curve never end. So if it's remodeled by that, it's going on forever. How long does it take to complete one full cycle? The period will equal 2 pi over b. It's kind of cool. B and p have the same equation. They're not the same number. They have the same equation. So 2 pi over 5 multiplied by 5 over pi. And it takes 10 seconds for it to go all the way back to make one complete swing of the pendulum. Okay, expand. It wants to expand x plus 3 to the 4th. So I would tell you, go ahead and use Pascal's triangle. This is the row we want. Remember, this is row 0, row 1, 2, 3, and 4. We can tell by that first number there. So we have 1, 4, 6, 4, 1. We start with x to the 4th, x to the 5th, x to the 6th. Sorry. That's another full class ticket. X to the 3rd, x squared, x to the 1, x to the 0. This one's going to be 3 to the 4th, 3 to the 3rd, 3 squared, 3 to the 1, 3 to the 0. So that gives us x to the 4th plus 3 to the 1 is 3 times 4 is 12, x cubed plus 3 squared is 9. 9 times 6 is 54. X squared plus 3 cubed is 27. 4 times 27 is 108. Plus 3 to the 4th, which is 81. Got her. Expand this guy to the 3rd. So I'm going to use the 3rd row of Pascal's triangle. So we have 1, 3, 3, 1. We'll start out with 2x. 2x to the 3rd. 2x squared. 2x to the 1. 2x to 0. Then we have negative 3y to the 3rd. Negative 3y squared. Negative 3y to the 1, 0. So it's going to be 8x to the 3rd. 2 squared is 4. 4 times 3 is 12. 12 times negative 3 is negative 36. X squared y. 2 to the 1 is 2. 2 times 3 is 6. Negative 3 squared is 9. 9 times 6 is a positive 54. Xy squared. Negative 3 to the 3rd is negative 27. Y to the 3rd. And we're done. Okay, it says factor this over the integers. So over the integers, I would hippo butt, x to the 4th is what? Times what? Factors of 20, add the negative 9. Seems to me like it would be negative 5, negative 4. This is a difference of squares. X squared minus 5 times x plus 2, x minus 2. Over the integers, you're done. Now if we go over the real numbers, it's the same number we just did. The only thing now that we can do is we can now factor this guy further. Since it's over the real numbers, x plus the square root of 5, x minus the square root of 5, x plus 2, x minus 2. Okay? And we're done. Okay, I'm going to stop here, take a little break.